Hello, grade 11s. We met again. Today we're still going to do maths, but we are just trying to recap on what we've done on your paper 1. So as you can see, the title for today's lesson, it's the exam preparation for your paper 1. We'll try and talk about the things that you might expect in your paper 1 that is covered in your first term. The following topics are examined in paper 1. Algebraic expressions, which is what we started with in the beginning of the year, exponents and sets, number patterns, algebraic and equations and inequalities, where you've got your simultaneous equations as well, and then your functions. We try and cover as much as we can just to prepare you for your paper 1. Now, guys, please be reminded, the work that we do in grade 11, it carries much weight when you get to your grade 12. You see, the things that we're doing in grade 11, most of them, they appear on your first few questions of the grade 12 paper 1. And what we are doing now, your first DBE paper, question 1, it's things that you've done in grade 11. So that 23, 25 marks, 28, it's just giveaway marks because it's things that we treating more in grade 11. And please be reminded again, guys, that whatever we do now, keep on going back, and because maths, it builds on the previous grades. So don't say now, I am doing functions of finance and whatnot, then I'm going to forget about algebraic expressions and so forth. So our first question that I'm going to ask you to do just in 2 minutes, simplify the following without the use of a calculator. Oh, goodness, it's moving again. Right. Now, without a use of a calculator, and it's easy to catch you guys when you've used a calculator, but if you are smart enough using your natural display, it's not easy to catch you. All right, so now 2 minutes, let's do this problem, simplify it as quick as possible so that we can get to more problems for the day. Right, let's go, 2 minutes. All right, grade 11, let's just check if we're all doing the right thing. Now, you've got the 15, 10, 125, 9, and 2. Please, let's go back. What we need to do, we must make sure that we write it according to our prime basis. Remember, the first prime being 2, the next one 3, 5, and so forth, all right? Now, if you look, how can you break down the 15 to its prime factors? And then at 3, I mean at 10, 125, and a 9, okay? So now what you do is, the 15 is 3 times 5, guys. But this is all to exponent 2n plus 3 times. A 10 is 5 times 2 to n minus 1. Divide by. A 9 is 3 times 3 n plus 1 times 125. It's 5 times 5 times 5, which is, that's 3n times 2 to exponent n plus 2. Now, let's check if these are prime. Now, remember, a prime number is the one that has got factor 1 and itself. So now 3, you can only have 1 times 3, all right? 5, it's 5 times 1. Now, if you look at 15, that's 1 times 15 and 3 times 5. Let's take, for instance, 10, right? That's 5 times 2. So it means that it's not prime, right? So now we move on. Remember the rule in grade 10, we had AB to exponent n. Now, what does this mean? This has got an exponent of 1, exponent of 1. So now we're going to multiply the exponents, 1 times n, 1 times n. You get a to n times b to n. It's still one and the same thing here. You've got your 3 to 2n plus 3 times 5 to 2n plus 3 times 5 to n minus 1 times 2 to n minus 1, all divided by 3 to 2n plus 2 times 5 to 3n times 2 to n plus 2. All right. Now, guys, let me just caution you on something here. You see, when it comes to this point, you see where I'm pointing, guys? This part. Okay, let's get a different color. Here, we are all able to see that 9 is 3 squared. But that 3 squared is to exponent n plus 1, right? So that 2 multiplies into the n plus 1. We often forget that the 2 multiplies to n plus 1, and then we end up having 2n plus 1. Like, let's make sure that we are aware of that. Now, remember that when we are multiplying the exponents, I mean the same bases, we add the exponents, and then if we're dividing, we write one base and then subtract the exponents. Okay, we start with base 3. You've got your 3 to exponent 2n plus 3. Where's the other 3? It's dividing. So what you need to do, subtract the exponents. So it's minus 2n minus 2. Right, times, for 5, you've got your 2n plus 3. Okay. And then it's dividing by, okay, there's a plus n minus 1. Then you subtract the 3n times the 2 to n minus 1 minus n minus 2. Okay. Now, we have simplified it, and then we've got the 3 to exponent 2n plus 3 minus 2n. And then now what we need to do is to collect the like terms, all right? So with the like terms, you've got your 2n minus 2n, and that's 0. Then we're left with a 3 to exponent 3 minus 2, that's a 1, times 5. The 2n plus n minus 3n is 0. 3 minus 1, that's a 2. So you've got 5 to 2 times 2 to exponent n minus n, it's 0. And then you're left with a minus 1 minus 2, which is a minus 3. Now, what we left with is the 3 times 25 times 1 over 2 to 3, which gives us your 75. The 3 times 25, that's 75, all divided by 8. Well done to those of you who've got it right. And these type of questions, they always be there. But guys, please make sure that you go back and check. If you get a complicated answer, like your maybe 2 to exponent minus x plus 5, blah, 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 just go back if you didn't make a mistake up there. All right. Now, let's look on to the next problem, right? So this is a minus. Guys, let's quickly work on this problem, and then I'm giving you 2 minutes again, and then from there, I'm going to help you on how to sort out this problem. Let's go, 2 minutes. All right, boys and girls, let's just check this type of question. If you have an operation sign negative or a plus between your terms, in this case, you have a 4n, 2 to 2n plus 3 separated by a minus. You always have to take out a common factor, all right? Sometimes if you don't see it, it's not there yet, you have to make sure that the common factor is there. And then later, your problem is going to divide that common factor. Most of the cases, it's going to divide the denominator and the numerator and whatnot. Okay, right now, let's look at this problem. You've got 4 to n. It's easy to work with them when it's simplified to prime bases. So here, you can say this is 2 to exponent 2n minus 2 to 2n times, times 2 to 3, all divided by 2 to exponent 2n times 7. Now, guys, this part, it's always giving learners a problem. If I give you x minus 5x, for instance, okay, maybe xp, I want you to factorize that by taking out a common factor. We're going back to grade 8 now. Everyone does realize that x is a common factor. And then you write, this is x bracket minus 5p. Most of us will do that. So I always suggest that if there's no coefficient, put a 1. This is 1 times something, so that you can be able to see that this should be a 1. One learner wrote to me and then said, this is x bracket fresh air minus 5p. Guys, there's no fresh air in mathematics. You should put a 1. So what do I mean by that? There's a 1 there. So this is, now your common factor is 2 to exponent 2n bracket 1 minus 2 to exponent 3 all over 2 to exponent 2n times 7. And then what I was talking about is that your common factor then now divides with that. Now it's now becoming very much easier. You've got a 1 minus 2 to 3. 2 to 3 is not 6. It is 8. So you've got 1 minus 8 over 7, which is minus 7 over 7, and that gives us a negative 1. So that simplifies to m minus 1. But the most important thing for us to tackle that problem was to take out a common factor, which was 2 to exponent 2n. All right? Now I can see, guys, that you need something. Just go stretch a bit, and then we come back after break. We continue. All right, guys, welcome back, grade 11s. I'm sure you are fired up. You want to go into this thing and then work. Simplify the following without the use of a calculator, showing working when necessary. This is where I said it's not easy for us to catch you if you've used your natural display, but as long as you follow all the steps, right? Because of time, we're just going to look at this. First part, your 75. How do you break it down? That's 25. Okay. That's, okay. Right. If you're using a calculator, you just put it in straight and then say 75, all right? So that is 25, it's 5 root 3. But if you are doing it manually, of which we don't mark this step, you're going to say that's 25 times 3. Minus the 12 is 4 times 3 plus. Now you go to 147. What is 147 divided by 3? Get 49. So you've got the square root. It's a plus square root of 49 times 3. And then the 108 is going to be the square root of 108. Now, guys, I've seen that there's going to be a 3 somewhere. 108 over 3, which gives us 36. That's 36 times. Now, that is... Yeah, we said 36 times 3 minus 16 times 3. Now, guys, your calculator, when it comes to this stage, what you do is you say, okay, 75, square root 75. It's going to give you straight to this step that I'm going to be doing now. The square root of 25 is 5. Then you've got 5 root 3. Minus square root of 4 is 2 root 3. Plus square root of 49 is 7 root 3. All divided by root of 36 is 6 root 3. Minus of 16, that's 4 root 3. Now, what we can do, if you just press the whole thing in the calculator and then it gives you an answer, then that we can easily tell that you have used your calculator. But now if you press square root of 75 equals to, it gives you 5 root 3, and then you write all of them like that, and then you can see that these now are like terms. 5 root 3 minus 2 root 3, that is 3 root 3, plus 7 root 3, which gives us 10 root 3, all divided by 6 root 3 minus 4 root 3, you get 2 root 3. And then from there, this and that. Divide, so root 3, divide root 3, and then 10 over 2 is 5. So now, guys, if you look, oh goodness, if you look onto this part, what you can do to check your answer, you type in the whole thing. That's root 75, okay, minus root 12 plus root plus square root 147, and then you go down, root 108 was 108, okay, and then minus square root of 48. Then your answer is 5. So you can easily check yourself using a calculator that you've done the correct thing. Now, Again, this is a similar situation, but when they ask you to simplify, this is the cube root of the square root of x to 1 over 2 all to exponent minus 12, okay? Now remember the brackets. You start with whatever is in the bracket first, simplify it, and then you go to the outside. So if you look, this is x to exponent half. We deal with the bracket, right? So this is x to half, and there's a hidden 2 there, right? So it means that you'll divide your denominator by 2, so you get x to exponent half over 2, which is 1 over 4, right? So I've dealt with this part, and then I still have a cube root there, all to exponent minus 12, okay? Now, I have that cube, like this is the cube root of x to exponent 1 over 4. This 3 divides the denominator. Remember, guys, if I've got a, and then there's b there, this is a to exponent 1 over b. So I'm always going to divide the numerator or your exponent by that 3 or 5th or whatever. So now it means that here I've got x to exponent 1 over 4 divided by 3, which is 1 over 4 times 1 over 3, and that's 1 over 12, but all to exponent minus 12, which now gives us 1 over 12 times negative 12, that's x to exponent minus 1. Now remember, guys, when you're dealing with your exponents, you leave your answers to positive exponents, so this is 1 over x. So that whole thing, it might look complicated, but if you start with the inside and then simplify it first, and then you go to the outside bracket or outside exponent, then you will be fine. Okay. Now, guys, with this one again, you need to simplify without the use of a calculator. I'm going to just give you only 1 minute, guys, because of time and we have to cover a lot. Giving you just 1 minute. Let's do this. At least we have the first 3 steps, and then I'm going to help you from there. Let's just take 1 minute. All right, welcome back, guys. Let's check if we're doing a correct thing or not. All right. Now, if we look at our problem, we've got an operation sign plus between the terms. And then here we have x minus 2 and the 2 minus x. And what we've learned in grade 10 is that if it starts with a 2 minus, and then we can introduce a negative, and then your x minus 2. So we start from there, right? So this is x, bracket x minus 2, right? Now, minus bracket x minus 2, right? Divide by, that is, the common factor here is 3 bracket x minus 3. Okay? Now, divide by, and you can now say multiply by. Remember, flipping times, okay? You've got, this will become your numerator, which is x squared minus 3x minus 6, divide by, just bear in mind with this part, it doesn't factorize, guys. The factors of 6, that would give you a 3. They're not there, right? Not unless you use a quadratic formula, but let's see how this problem takes us. You've got an x squared minus 4. That's a difference of 2 squares. That's your x minus 2, and then x plus 2, right? Now, next, we have a common factor here of x minus 2. Again, I said put a 1 times, okay? So you have x minus 2 as our common factor, bracket x minus 1, okay? All over 3 bracket x minus 3, right, times by x squared minus 3x minus 6, all over x minus 2, x plus 2. All right? Now, from there, guys, what you need to do is you look at your like terms, okay? This bracket x minus 2 divides the x minus 2. And then from there, guys, we just need to check. There is an error here, all right? This should have factorized, and then that part should have divided by that part, okay? So now I'm going to check for you on this part. It's not supposed to be x squared minus 3x minus 6, and then we'll continue with this problem. But what I'm trying to say is this should factorize either to the x minus 3, x plus 2. It means that, okay, guys, this was a minus 1, so this part is not there. Now, if we fix that problem, just check with me at school, all right? So if we fix that part, then this now does factorize to, okay, this is minus x, and then that is x minus 3, and then x plus 2, all right? Guys, now bear in mind what I've done is I looked at that problem. This is x squared minus 3x minus 6. You can't factorize that, not unless you complete a square or using a quadratic formula if you're solving and so forth, okay? So now, if it's x squared minus x minus 6, then you are able to factorize, then it becomes x minus 3, x plus 2. So now this, the x minus 3 divides the x minus 3, the x plus 2 divides the x plus 2, and then your final answer should be x minus 1 all over 3. Okay, so that's how you solve that expression. And now, guys, very important. Now, if you look at how I'm setting up my problem, this is an expression. And remember, with an expression, you write your equals to on the side, right? So equals to, you know, like writing it's a poem and whatnot. There's no equals to, and then we don't know where you are going with your problem. And you don't have two equal signs. Some of us, we've got a tendency. Some of us, we can just have, this times, I feel like putting it to an equals to, because I say this is a cross, then I can just change it to equals to. You don't just do as you wish. You follow all the basic requirements. Okay. All right, guys, let's move on to the next problem. All right. So we've got the next one. Examine the following sequences and answer the questions that follow. 1, 2, 4, 5, 7, 8, 10, 11, 13, 1, 1, 8, 1, 2, 4, 5, 7, 10, 10, 17, 13, 101. Give the next three terms in the sequence after the 13. Okay. If you look, there's a 13 here. So what's going to be the next one after the 13? All right. And now describe the pattern recognizable in words. All right. And then calculate the number of terms in the sequence. Right. So now I'm going to give you this problem. You sit with a friend during break, and then you work it, and then from there we do it together. Let's go. You go get some water, and then from there you work with a friend. Let's go for break. All right, guys, let's just check if we're on the right track. it looks a bit confusing because what we are used to as to maybe say 1, 2, 3, 4, 5, 6, or 1, 3, 5, 7, 9, and so forth. But with this pattern, if we check, this is 1, 2, there's a difference of 1, but then there's 2, there's now 1, 2, 1, 2, 1, 2, 1. So it means you're going to have 14, and then 2, that's 16, 1, that's 17. Okay? So you can look at it that way. Or the first one, what you can do, because you can see that it's now, this one, if you split this pattern, you'll have a 1, 4, 7, okay, 1, 4, 7, 10, 13. I hope you see what I'm doing. I'm splitting these sequences. I'm taking one, the second one out, the fourth one, the sixth. So now if I've got 1, 4, 7, 10, all right, 13. Guys, see what's happening here. The difference is 3, all right? So it means that the next one is 16. The next one, it's going to be 19, right? Now, bearing in mind that I still have this one and that one. But let's look at that other pattern. That's 2, 5, 8, 11. You see? A jump of 3. So 11 plus 3, that will be 14. 14 plus 3, that will be 17. So it means that that's going to be 14 and then 17. So whichever way you look at it, at the end of the day, you'll get the pattern. So the next terms, it's going to be 14, 16, 17. As like it doesn't make sense. The pattern doesn't follow. But now if you split the sequences, you'll be able to work it out. Okay. So now that's the first part. Okay, we've had 2, 5, 7, 10. Okay. Now, give the next 3 terms in the sequence after 13. So if you look at the next one, some of us will say, no, this is the same. 1, 2, 4, 5, 7, then 10, 10, 17, 13. You see? Now, you have to open your mathematical eyes here. You have, this is, like I said on the first problem, if you split, this is 1, 4, 7, 10, 13. 1, 4, 7, 10, 13. Right? Now, what's going to be the next one? The next one we jump. So I'm looking at this. So what's happening? I keep on adding a 3. So that's going to be 16. All right? So 16 is going to be there. Now let's look at this one. That's 2, 5, 10, 17. This one is different now. You've got, this is 3, 5, 7. You see what's happening now? Your first difference is 3, 5, 7. So it means that this will be a 9. So this is 26. Now that will be your 26. Okay? Now the next one will be 11. So it means that you will have a 37. So the next 3 terms will be 26, 16, and then 37. Confusing, huh? But doable. All right. So if you split those problems, you will be able to see the pattern. All right. So now the next one, you can be able to describe it in words. All right. So, and some of the acceptable answers, like if you say these are patterns within patterns, and then the top one is a linear pattern, but if you split them, you keep on adding a 3 for every term. The first term, you need to add a 3 to get to the second term, and so forth. It depends on how you are going to be describing it in words. All right. Now, so calculating the number of terms in the sequence, I'll just do the first one. if you look, this is 1, 4, 7, okay, 7, 10. And then this is 2, 5, 8, 11. Okay? And then this pattern continues up to 108. Okay? So this is, you can work out what your Tn is. So Tn will be 3n minus 2. All right? And then your last term, if you check, this one, it differs by 2. Here it differs by 1. Let's check if 118 is part of this sequence. If you look at your 118 is 3n minus 2, then you get 120 divided by 3 is 40. So that there will be 40 terms for that sequence. And then you can do the same. Work out your general term, your Tn first, and then see if that one falls part. If you were to do all of them, you'll be able to say that there's going to be 40 terms there. Right. Now, next part, you need to solve for x. You've got x squared minus x minus 1. Normally, we look at this problem and say, okay, let's factorize. And then now you've got x squared minus x minus 1. You can't factorize. If it was a 2 here, it's possible, x minus 2, x plus 1. But one other way of solving is to use a quadratic formula, or you complete a square. The easier part will be to use a quadratic formula. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. And then it's in the form of x squared plus bx plus c. So minus b is minus 1. Then you get 1 plus or minus square root of minus 1 times minus 1. 1 minus 4 bracket 1 minus 1 all over 2a is 1. Then you've got your 1 plus or minus the square root of 4 plus 1. It's a 5 all over 2. And then now, depending on what does the question want from you, if it says leave your answer to 2 decimal digits, and then you press your calculator SD, and then you've got it to your 2 decimal places. But if they said leave it in your set form, then your x is that. Now, another part of the work that we did this year was to work out solving using the sets and so forth. And then the first thing was to make sure that the one with the square root is on its own side, all right? And then you square on both sides. So if you square on both sides, you're going to get 8x plus 16, because that 2 becomes your 8x plus 16 all to exponent half times 2. And then on the left-hand side, where we normally make a mistake, you guys, you leave it as 2x plus 1, but in actual fact, it is 4x squared plus 4x plus 1, because you've got your 2x plus 1 times the 2x plus 1, FOIL it out, and then you get 4x squared plus 4x plus 1, which simplifies to 4x squared minus 4x, okay, minus 15, okay, equals to 0. Let's now see if it does factorize, okay. Let's check. Equals to 0. Then if you've got your 2x, and then your 2x, and then 5 and 3, that's 10, and then a 6, so this should be a minus, and then that is a plus. Or some of us, when we get here, you're not sure if it's going to factorize, then you go to your quadratic formula. All right, now, so you get x is minus 3 over 2, or x is 5 over 2. Most of us in grade 11, what we do is we leave it just there, but you have to check your solution. If your left-hand side does give you the right-hand side. For this, if I take my left-hand side, I substitute by minus 3 over 2. I get the left-hand side to be 2 times minus 3 over 2. I get minus 3 plus 1, which is minus 2. And then taking the right-hand side, I will have the minus 3 over 2, 8 by minus 3 over 2. That's minus 12 plus 16, which gives us a 4. Square root of 4 is 2. Right. Now, if you look at your left-hand side, that's minus 2, and then your right-hand side is positive 2. Before we even do all this, we can just see that if I get a negative answer on my left-hand side, surely my right-hand side will never be negative. The square root of whatever is in the square root should always be positive. How do you represent this? This is not equal to minus 3 over 2. Why? Because your left-hand side is not equal to your right-hand side. Now let's try 5 over 2. If you substitute by 5 over 2 on the left-hand side, you get 5 plus 1, it's 6. Left is 6. Right? You put 5 over 2, then you get 20, and then that's 36. Square root of 36 is 6. Your left is 6, your right is 6. Therefore, this is a correct answer. Then you say x is positive 5 over 2 only is a solution to this problem. I hope you are now refreshed that we don't stop there. We go back and check our solution. All right? Now, comes the other one that we normally struggle with, your inequalities. All right? Now, this, you treat it as a graph, right? Y equals to 4x squared minus 25. Okay, where do I have my solution? If I look at this, I will get positive 5 over 2 and minus 5 over 2. 5 over 2 minus 5 over 2. And then this graph is positive. Where is my graph negative? Where are the y values negative? It's in this region, okay? So when x is between minus 5 over 2 and 3 over 2. Now, how do you do it algebraically? You've got to factorize difference of two squares. You've got to 2x, 5, and then 5 minus and plus. Your critical values minus 5 over 2, and then positive 5 over 2. Your rough parabola sketch, and then less than, so below the graph. So therefore, your x is between minus 5 over 2 and 5 over 2 and including. Okay? Right. Now, let's see the next part. Guys, I want you to listen very, very carefully here, even though we did it in the past, but let's just make sure, because your completion of a square, it takes you to your graphs in the form of y equals to a into x minus p squared plus q. Okay? First of all, we make sure that we transpose the c part. It should be in the form of ax squared plus bx plus c. So you get your 3x squared plus 5x is 12, right? Next, your coefficient of x squared should be a 1. So if there's something next to x, I'm going to divide by that throughout. So I get x squared plus 5 over 3x is 12 over 3. That's a 4. Then next, this is a positive, okay? Open bracket, you square the results equals to 4. I'm taking x of x squared plus, you have the coefficient of x, which is 5 over 3 divided by 2, and that's 5 over 6. And then you square the results. There is something that is happening on the left-hand side. You get x squared plus 5 over 3x plus 25 over 36. Whatever you do on the left-hand side, you must also do it on the right-hand side. So I've added a 25 over 36, so I have to add 25 over 36. Then this is x plus 5 over 6 squared equals to, now let's simplify this. Your 4 plus 25 over 36, that's 36 times 4 plus 25, which gives us 169, okay? So you get 169 over 36. Now, you want to remove that square. You'll square root on both sides. Now remember, if I've got x squared is 9, I'm square rooting on both sides. I can have either minus 3 or plus 3 in that place of x, so it's plus or minus. So we've got plus or minus, then that's x plus 5 over 6 equals to plus or minus root 169 is 13 over root 36 is 6. Then you get your x is minus 5 over 6 plus 13 over 6, or minus 5 over 6 minus 13 over 6, which gives us x equals to, now this is not 16, it's 6, right? You get, what am I doing? This is 8, that's 8 over 6. And then this side I've got minus 18 over 6. And then you can simplify this to x is 4 over 3 or minus 9 over 3, which is negative 3. I'm doing it like you guys. Okay, so your x is 4 over 3 or x is negative 3. Okay, right? Now, this is what I wanted us to talk about. Find the equation of the parabola, all right, which is part of your term 1, which has a turning point at minus 3 minus 4 and passes through the point minus 1, 12. Give your answer in the form y equals to a into x minus p squared plus q. The minute they give you a turning point, it's in the form of y equals to a into x minus p squared plus q, where your p is negative 3 and your q is negative 4. So you've got your y is a bracket x plus 3 all squared plus q is minus 4, right? And then the point is 12 and minus 1. So y is 12 equals to a into minus 1 plus 3 all squared minus 4. Then you get your 16 is a bracket 2 squared is 4. A is 4. So in other words, we have your y is a is 4 bracket x plus 3 squared minus 4. You can just go and check the most important part for us in this problem was to get the value of a. But now how do you get the value of a? You are given the turning point. And the minute they give you a turning point, so it's in the turning point format, which is y equals to a bracket x minus p squared plus q, right? Now, the p is given, it's minus 3. The q is given, it's minus 4. What you do is you substitute in your equation. They have to give another information, and then the next information is that we have given you the turning point, and then the point is minus 1, 12. So this is x and y. What you do is you now go to your problem. Y is 16, x is minus 1. Then you've got only one unknown, which is now a. Simplifies, this is 3 minus 1, which is a 2 squared, and that's a 4. Take the minus 4 across, 12 plus 4 is 16. Then you've got your a is 4. Then what you need to do is then substitute back to the original equation, which is given in the form of y equals to a into x minus p squared plus q. Substitute a, p, and q. I hope this session has helped you to revise your paper 1. As for me, till next time, bye-bye.